Alright, welcome to Angles Formed by Two Vertices, Level 2. Now, in this video, what I've actually done is we're taking a vertex that is on the circle and a vertex inside the circle, and we're actually going to combine both of these concepts. The reason that I chose this for the Level 2 video rather than Level 1 is because I think this is where it starts to feel a little bit cluttered. Now, how can we start this so it doesn't feel cluttered? Well, we want to go here to arc FC, and I'm going to use this in red to indicate, hey, this is the arc that is shared by both, let me show y'all, shared by both this angle from C to H to F, and then using this golden color, we see that we have this vertex right here formed by these two lines, but they still both share that same subtended arc, FC, which I have in red. Now, let me go ahead and switch over back to this gold, because this is where we're actually going to start our problem. So, I noticed that for this gold arc, I have this arc right here, arc DE is 68 degrees, and this angle of 52 degrees. And I want to ask myself, well, where I see this point G, this vertex, is this a vertex that is inside, on, or outside of the circle? And we see very clearly that G is what we would consider to be a vertex that is inside the circle. Okay? It is, in fact, inside the circle. Now this implies we'll use this formula. The measure of angle 1 equals 1/2 arc X, and in this case, plus arc Y. Now, what I want to do from here is I want to fill in everything that I know. So I see right here at my vertex we have 52. And remember, at the vertex is where you'll always find the angle because these two lines form a sharp point. And so 52 equals 1/2 parentheses. And arc X, is that my large arc? Is it my small arc? What do you think? And yeah, you're absolutely right. It's our large arc, and so I know that the 68 is the large arc. Why? Because it's bigger than the 52. The other arc must be smaller than the 52. Plus Y. Now, to start this off, we're going to use a very simple trick to get rid of the 1/2. Well, what is the opposite of multiplying by 1/2? That would actually be multiplying by 2. And so these actually cross each other out. But since I multiplied the right side by 2, I have to multiply the left side by 2. And so we know that 2 times 52 will of course give us 104, and this equals 68 plus arc Y. Now from here it's relatively straightforward. Because these two things are being added, 68 plus arc Y, we're under the rules of addition and subtraction. And in order to get rid of a positive, we essentially need to subtract, or show the opposite, a negative, away. And if I subtract 68 from the right side, well of course I have to subtract 68 from the left side. Now, I've lost my calculator for the moment, so let's just go ahead and do some simple math here, okay? So I rob that, becomes a 10, rob that, 9. Okay, put that 1 there. We know 14 minus 8 will give us 6. 9 minus 6 will give us 3. And it turns out arc Y is equal to 36 degrees. And once again, where's arc Y? Well, let me go ahead and switch back to that red. And we know that that is the subtended arc that we did not know. It's now 36 degrees. Well, of course, this brings us to answering the actual question. Find the angle CHF. And I know that C goes from C to H to F. And we're actually looking at this vertex right here. Now, what would you call vertex H? Is that vertex inside, on, or outside the circle? And of course, this is what we call a vertex on the circle because it's essentially on that outside edge. And so now we'll use the formula, the measure, oh, here, let me get rid of that. The measure of angle 1 equals 1/2 arc X. Very simple formula. Let me even make that arc a little bit nicer. So let's plug in the things that we know. We know we have the measure of angle 1, what we're looking for, is equal to 1/2 times, and we see of course that subtended arc is 36 degrees. And remember, when two things are side by side, they're being multiplied, and we know that 1/2 times 36 is essentially asking us what is half of 36, and that is 18 degrees. Okay, and it turns out the answer to the question is going to be 18 degrees. I would encourage you to pause the video right here. Go ahead and finish taking the notes as necessary. And all right, now for example 2, we see that given angle DGE equals 41 degrees, and we see that arc DE is 63 degrees. They want us to find the measure of angle DHG. So let's go ahead and start filling in all the information we know. Well, the first thing I actually want to do is I want to find where is the arc that both the vertex inside and the vertex on, what arc is it that they share. So I'm actually going to go ahead and take my red and really embolden that. Now to stay consistent with my previous 3 examples, I'm going to take gold and I'll use that to represent my vertex right here. And then let's go ahead and use this magenta and just kind of show this angle right there. Okay. Well, now I think we can go ahead and start filling in all the things that we know. So the first thing we see is that angle, we see that sharp point means angle. Angle DGE, so let's see, so I start at D, I go to G, and to E. So this must be 41 degrees. And I also see the arc DE, which I see right there, is 63 degrees. Now this brings us to our biggest question in all of these problems. Is this now a vertex that is inside, on, or outside of the circle? And when I look at this, I clearly see it's a vertex that is inside the circle. Yeah, I almost wrote on, but yeah, it's a vertex inside the circle. And that actually implies that we'll use this formula. The measure of angle 1 equals 1/2 parentheses arc x plus arc y. And I've said it before, I'll say it again. We know that arc x is always the larger arc. So let's take a look here. At the vertex, or where the angle is formed, I see 41 degrees is equal to 1/2 parentheses. And because 63 is bigger than 41, I know it must be my arc x, and arc y is actually going to be the smaller of the two. Well, at this point, we want to get arc y by itself, and we ask ourselves, what is our first step? And of course, it's our trick to get rid of 1/2. And to get rid of 1/2, we multiply times 2. Now recall that the 1/2 and the 2 cancel, but if I multiply the right side by 2, well, I also must multiply the left side. Now I know that 2 times 41 will of course give me 82 equals 63 plus arc y. And then from there, I want to ask myself, well, how do I get rid of this positive 63? Of course, I'll take the opposite, which is a negative, and so minus 63 on both sides. And we know that 82 minus 63, I believe that's going to be 19, but let's just double check here. So 82 minus 63, yeah, and then of course that will give us 19. But better safe than sorry. Okay, so I come over here and I write 19 degrees. Now from there, let me go ahead and switch to my magenta. So now we know that arc is 19 degrees. And we're now trying to find this angle right there. And so we ask ourselves, well, once again, what is that vertex? Is it inside, on, or outside? And of course, in this case, this is something that we would call a vertex that is on the circle. Well, why is that important? Well, that's telling us, hey, we need to use this formula right here. The measure of angle 1 is equal to 1/2 parentheses. And of course, I know that the arc is 19 degrees. And now all I have to do is, since these two things are beside each other, is simply multiply. So say, okay, well, the measure of angle 1 must equal, and 1/2 of 19 looks to be 9.5 degrees. Okay, we can go ahead and write that in, 9.5 degrees. All right, well, I hope that these 2 videos helped you out.